Hi everyone, this is another sort of special bonus solve. I'm going to be solving 6 puzzles today. These are part of Guess Who. So these were the puzzles for March 2nd, 2024, and we were celebrating our 1000th day of Gas. So for the past 1000 days we have been posting a daily genuinely approachable Sudoku. And so to celebrate, we did Guess Who. This is something we've done before a number of times, and typically we will each make a 6x6 Sudoku, and we will post all of them without telling you who set which. So in addition to solving puzzles, you get a guessing game. You get to try and figure out which puzzle was set by which setter. This time we did double that, so we have a set of 3 letters, G, A, and S, filling gas. And then we also have a set of 1000 puzzles. So one of the letters was set by Clover, one was set by Bill, and one was set by me. And the same for the 1000 puzzles. So let's just go through them in the order that they were posted. I will not reveal which one was set by which setter until the end of the video, in case you want to play along and guess. So the first one is the G, and it is a Modular Lines Sudoku. So all of these are 6x6. We're going to have normal 6x6 rules, 1 to 6 in each row, column, and 2x3 box. Additionally, in this puzzle we have modular lines. So this can be confusing if you're not familiar with the math term. Modular in this context is talking about remainders. So when we divide the digits from 1 to 6 by 3, it splits them into 3 groups. One group has a remainder of 0, so 3 and 6 are just divisible by 3. One group has a remainder of 1, those are 1 and 4. We divide 4 by 3, we get 1 with a remainder of 1. And then the other 2 digits, 2 and 5, have a remainder of 2. So we're splitting those into 3 groups, and the modular line rule is saying that any set of 3 cells along the line, in order, say these 3 cells, must contain 1 digit from each of those sets. So one of these has to have a remainder of 0, one has to have a remainder of 1, and one has to have a remainder of 2. Now that has a consequence on the whole line, which is not immediately obvious from the rules. But we're going to go through that now, because it's important for solving. So I'm just going to color them blue, green, orange. We don't know what remainder those correspond to yet. But let's look at this cell. This cell is part of this set of 3 cells along the same line, and we already know that we have a green and an orange. So we still need a blue. That has to be blue. Now these 3 cells are also a set, and we don't have a green, so this has to be green. These 3 cells are part of the set. We don't have an orange. And so you can see what's happening, blue, green, orange, blue, green, orange. We're just going to repeat the pattern all the way along the line. So whatever order these are in for 3 cells, they're going to stay in that order. So I'm just going to stick with this coloring and color all the cells in the line. And going backwards, this is orange, green, blue, and orange. So now what we want to think about is which color corresponds to which remainder. And we're going to start by looking in the top row. We already have a 1. Wherever the remainder of 1 is, we've already got one of those digits. So, can it be blue? Well, these 2 blues see each other. If they both have a remainder of 1, they're 1 and 4. But obviously that doesn't work. We already have the 1. The same is true for orange. We can't place both 1 and 4 in orange because we already have a 1. So the only place we can have a remainder of 1 is this cell. It has to be a 4 because we already have a 1. So 1 is green. And now we can resolve all of the green cells along the line. This has to be 1 or 4, but it's in the same box as 4, so it's a 1. This is in the same column as that 1. This is in the same row as the 4. And now this could be 1 or 4 if we didn't have any other information. But we have 2 1s looking into this box. And 1 can't go in blue because blue does not have a remainder. Green does. So the only place for 1 in this box is here. So that resolves all the green cells on the line. And now we can look at row 4 and do the same sort of thing. Blue does not have a remainder of 1, because green does. It also doesn't have a remainder of 0, because if it did, we would need both 3 and 6 in this row, and there's already a 3. So blue is 2 and 5. And we can start here. We know that's a 5 because there's 2 in the box. Both of these have to be 2. This has to be 5. And then these are going to be a 2. No, they're not going to be a 2 because there's a 2 already. Alright, and then orange, we have a 6 here because we already have a box. These can be 3, 6. These can be 3, 6. This can only. And at this point, we don't really need the coloring, so just remove it. And we can just use the digits that we placed in the pencil marks and solve the puzzle. So this is 3 or 6. Here we don't have a 5. And then 5 in this box can only be here. The last digit in this column is a 4. We're going to have a 2-4 pair in this box. And now our 4s are looking up in this box, and this is the place for 4. This is 3 or 6. This is also 3 or 6. This is 2. We still need a 5 in this row. We have a 6 here, and we still need a 1. And now this 6 is going to resolve all of our 6s. Resolve all of those. This is also 6. The 2 here resolves 4 and 2. 4 and that is how you solve the G puzzle. So now we'll go to A. A is an extra regions puzzle, and apparently it's a little hard to see for some people, so I'm going to color the extra regions. So normal rules, 1 to 6 in each row, column, and 3 box. Additionally, we have extra regions which also must contain 1 to 6, exactly once each. There is a 1 through 6 in blue, there's a 1 through 6 in orange. And the shapes of these, we can start looking at the givens that see a lot of cells. So if there's a 1 and 2 in the column, these are 1, 2, 4, 5, 6. But they're not 1 and 2, and we need a 1 and 2. So these are 1 and 2. The 1 here resolves them. This is not 5, this is not. Where does 3 go in this box? There's 3 there. Those are not 3. Now we need a 4 and a 6. There's a 4 here. We still need 2, 5, and 6 in this column. And so what are we missing from orange? We're missing 1. So same thing here. The 1 and the 2 had to go here. 1 and 3 had to go. This is an example of what's called the law of leftovers. If you have a house, so if you have a set of 1 to 6 in this case, a set of all the digits, so that could be a row, a column, a box, or an extra region. And then you have another one. So here we have a column, it contains 1 to 6. Here we have an extra region, it contains 1 to 6. The overlap is the same in both cases. So whatever is outside of the overlap has to also be the same. Alright. We've got 4 and 6 here, we've got 2 and 5 here. What else? We need a 3 in this box. These are going to be 1, 2, 5, and this is the only place for 4. So that's not 4, and that's the last place for 4 in this column. This is not 1. This is not 5 or 1, so that's 2 or 6. The 2 has to go here somewhere. What are we missing? This is the only place for 1. I can also see that this can't be 6 because the 6 in this box is in one of these cells. 2 is here somewhere. This is 5 or 6, and this is 2, 5, or 6. Now we have a triple here. So this is the only place for 1 and 3 in this order. This one. Now we need a 3 in this box. It's got to go there. That places 2. That places 5, 6. 2 and 5, 6, 5, 2, 6. 4 and 5 in this row. 6 and 4, 2 and 5. The last digit is 6. That's the solution to 8. For S, we have scattered sums. And this is kind of like having filler cages, but they're not together. So the clues outside the grid get the sum of the highlighted cells. So this column is telling us that these 2 green cells sum to 6. This column is telling us that these 3 green cells sum to 11. And they make a nice little S shape. And those are the rules. Normal 6x6 rules again. So we'll start here with our lowest clue. 4 has to be 1 and 3, so we can't have 2 2s. Now 6 in 2 cells can't be 3, 3, so instead it has to be 1 and 5. That gives us a 3 here, and then from either the 7 or the 5, you can see this has to be 11 in 2 cells in a 6x6 can only be 5, 6. That's the maximum you can put in 2 cells that see each other. 10 can only be 4, 6. So now let's look at the 11. We can't have a 6 here, because that would give a 5 here, and that's already 11. We wouldn't have any of this set. So this is a 4, 6, 5, 6. And now we have 10, we need a 1. For the 15, we need a 4. And that's all the clues. And so now we just are left with classic Sudoku. This has to be a 2 or 5. This has to be a 2, though. 4, 5, 6, 1, and 3. That's our 5. This can't be 6 in the box. 1, 4. These are 1 and 3 in the column, but we have 1 there. These are 2 and 3. We have 3, 2 in that order. We need a 2 in this box, so that's our 2. We need a 4 in this box, that's a 4. 5 and 6 in these 2 cells. We need 4 and 6 in this row. Now that we have this 4, 6, 4, 6, 5, and 6. These are 1, 5. The 4 here, though, tells us 1, 4, 1, 5. Here we need 3 and 5. Here we need 1 and 2. And we've got 1 here. So 2, 1, 2, 3, 3, 6. That's the solution for S. So now we're going to go on to the 1000 themed puzzles, starting with a Renban. So this one actually has 1, 0, 0, 0. The other 2 are a little different. And normal 6x6 rules again. Renban tells us that all of the digits on the line form a consecutive set in some order. So this line could be 4, 3, 5, 2. This. In the example, it could not be something like 6, 3, 1. We're skipping the 2. So those are the rules. All of these are 4 cells. And there are several different approaches we could have here. One is to consider what it means for a 4-cell Renban if there's no 5 on it. So if there's no 5 on this line, we can't have 6 either. So the only thing we could have. That's one way you could start this puzzle. Another thing you could look at is this 1. In this box, can 1 go on this line? Well, no, not with 5. We can't have 1 with 5. We're the only place where 1 is. So a couple of different things you can do. This line is similar to this line down here. The 5 in this column sees these 2 cells, the 5 in this row sees these cells. So instead of 1, 5 doing all the work, this time we have both of the 5s. But these are also 1. And none of these are 1. So this is our 1. This is our 5. This is 2, 3, or 4. This is also 2, 3, or 4. So it's 6 here. And this also can't be 6. So all of these are 2, 4. And we could have seen that directly from these 6s. 6s ruled off the line. We can't have 1 since there's already a 5. It has to be 5. This is not 3. This line also does not have 5. So it is 1, 4, 5. And this is going to be the only place for 6. None of these are 3, so this is 3. This also isn't 1. 1 is not here either, so it's here. 1. These aren't 3 or 4. Still need 6s. This is 4. This is 2 or 3, and there's 3 in the box, so that's 3. Now on this line, we have 2, 4, and up here, this is the only place for 3. These are 5 and 6 in some order. We need a 5 in this box. Let's do it here. So now it's all over 5, 6. The 2 here is 4. Now we have 1 and 2 on this line, so these are not 2. We need a 2 here, 4 here, 2 here, 4 here, 2 here. We could have gotten 4. This is not 4 either, and the 1 here doesn't make raise. 2s. The 3 here is 4 and 3, and 6, 4, 6. And that is 1,000. This is 1K. We have our lines this time in the shape of 1 and K. And I can tell you this was actually made after this one. So the same pattern for the 1 and K. And a similar pattern with the givens. This one has more givens. This is a region sum line. So I should pause this one. Region sum lines, wherever we have a line, we look at the cells that are entirely in one box, and the sum of these digits must be the same as the sum of these digits. So these are on the line in a different box. So this sum is equal to this sum. This sum is equal to this sum. This sum is equal to this sum. And those are the rules. So where to start in this one? So we know these aren't 4. There's 4 here. There's 4 here. This could be 4. It would be saying that this equals these together. 1, 2, 3 here. That would be a 3. We have 3, 4, 5, 6 here. That's not a 3. That's not a 5. That's not a 6. That's not a 3 or a 4. Okay. We have 3 here. So 3 is in one of these cells, which we already knew. So this is at most 9. And this can't be 4. It also can't be 5 or 6 because actually it could. This could be 5. No, it can't. So if this were 5, this would be 6. And that would reduce the maximum here And if this is 6, we're going to have at least 10. There's some better way to see that, I'm sure. But this is 1 or 2. Now, this is at least 7. So we can't have a 4 here. And now it's exactly 7. So this is a 4 pair. So 5, 6 pair. This can't be 4, so this is. So here we either have 5 or 6 is our sum. If we had 5, 1, 4, this would have to be 2, 3, and we can't do that. We have a 3 in the box. This has to be 2, 1. This is 6 and a 5, 1 and a 5, 3 and a 6, 4 and a 5, 2 and 6. We know the order there. These are 2, 3, 4. These are. Alright, here we have 1 and 2, so that's a 3. This is a 6. These are 1, 2, 5. We can't have a 1 here. That would give us 5, and we can't make 5 in cells. We could make 6 in cells. It would have to be 1, 2, 3. The problem is, if this is a 2, we can't make 1, 2, 3 because 2 would see all of the cells. So this is a 5. And again, there are multiple ways to work through this puzzle. The other way you could see that is there has to be a 6. And once there's a 6 up here, this definitely doesn't sum to 6. So in fact, we have 9 here. Since we have a 6 on the line, this has to be 6. So this is not 4. And these aren't 2, so 2, 6, and 1, 2, and 1. This is 1, this is 3, 4, 2, 4, 3, 3 and 6, 5 and 4, 3, 5. So there's a little working out of math to do in that one. It's not straightforward. This one gave people a little more trouble than the other ones. Yeah, so this one is a Whispers. They're colored green. Sometimes this is called German Whispers in 6x6, even though the rule is different in 6x6. But the rule in 6x6 typically, if you see a green line, is that digits and cells connected by the green line must differ by at least 3. And the justification for that is 3 is half of 6. In a 9x9, it's 5. 5 is half of 9 rounded up. Dutch Whispers in a 9x9 would be 4. In a 6x6, it's 2. So it's just 1 less than German Whispers, typically. But yeah, that's how that works. So for Whispers, just like with German Whispers in a 9x9, we have to alternate between a low digit and a high digit. If we put a low digit here, to get 3 away from this, we can't have another low digit. We can't have 1, 3, those are 2. So we would have 4, 5, 6. To get 3 away from this, we would have, and so on. So we're going to alternate, and I'm just going to pick this to be purple. These are green, this is purple, this is green, these are purple, this is green. And now we can think about what color is. We already have a 1 and a 2. They're low. So green cannot be low. That would give us too many low digits. So these are high, and these are low, and this one has to be a 2 here. 3 is 3 away from 6. It's too close to everything else. That's not 6, that's not. This could be 3. This can't be 4 because it's between 2 different digits. 4 can only go next to 1. This is not 6, so this is not 3. In fact, this is 4 or 5. So this is 6. This is going to be from 1 to 3. I could color this. Might as well. I haven't done enough coloring. Alright. So 5 is going to go down here somewhere. 6 in this box is going to put one of these cells. What else? This. Go ahead and color this line. So it's purple, green, purple, purple. Let's see if we can tell anything from that. It's not obvious what we can tell. If purple is low, this has to be 1, 3. We have to have a 6 here. Go in between. And this would have to be the 1. So like this. 5. 2 there. So that's 4. So that's force if purple is low. And I don't think that causes problems. Purple is high, this has 4, which means this has to be 1. This would have to be 5 or 6. This would have to be 2 because it's between purple cells. And then this would have to be 5 because it's 6 here, which means this can't be 5. So what we end up with is a 1, 6 pair and a 5 pair, which is very useful because that means this is I'm certain there's another way to see that, but I don't think that's how I did it. It's neat. Like, oh, that's this is for this. This is okay. Now we're back on track. This is our 5. So this is 1 or 2, and it's blue. These are blue. It's blue. Orange. This is orange. We have 1, 2 pair, so this is our 3. I have a 1, 2 pair here, so this is 3, 4. This is 5, 6. Now we have a 3, 4 pair here. So this is 1, 5, 6. This is not 6, so this is. I have a 1, 6 pair here, so this is just 5, 6, 5. And now that 6 is going to. So purple is low. Green is high. 6 and 5, 2, 3, 4, 3. So I'll keep coloring. Pretty pattern. These are 2 and 4. This is 4. Here, this is 3. 1 and 2. This is 4. And 4. Puzzle. 5, 4 here. You get 2 from this 1, 1. That's the solution. So that is all 6 puzzles. I hope you enjoyed them. So spoiler warning, if you haven't guessed already, I will go through who set each of these. So for the letter puzzles, I was actually the one that suggested doing this in the first place. And previously I don't think I've set a G puzzle. I tended to get stuck with A for whatever reason. I've probably set at least one G and at least one S. I didn't check before recording this, but I felt like doing a G. So I actually made 2 different Gs, and this was one of them. Clover was next to set one, and so she set an A, and Bill got stuck with the S and pulled up the puzzle. So I'm glad we stuck with this. For the other ones, so we set GAS in that order. We actually set these in the reverse order that they were posted. Clover set this one, and she said it first, and she was trying to do her best Philip impression, thus the whispers. And then I tried to set something that used the same pattern, 1K, and even used the same given digits, and I got close with a couple of different variants, but in the end I went with this some lines and added the extra givens, and this is just a very neat pattern, having one of each given digit. And Bill decided to do something completely different from our 1K and did 1000. And just a cool setup with these 4-cell Renbans, scene 5 and 6. and forcing all of them over here. We want 4, and this one not because the shape is different. So I hope you enjoyed those, and let us know how you did. Let us know how you did on the guessing. If you haven't been solving gas for a while, maybe you're not familiar with our styles, and maybe even if you are, we fooled you a little bit. But if not, that's okay. It's just a fun game. And we will be back tomorrow with another solve video. I am posting a killer today, I believe. I'll check the spreadsheet, but that should be up. And see you next time.